Students, welcome to our YouTube channel. Today we'll discuss basic character of amines. Amines are basic in nature. Amines are basic. Amines are basic in nature due to presence of lone pair of electron on nitrogen. Due to presence of lone pair of electrons on nitrogen. So they are a stronger basis than ammonia due to plus I effect causing group of alkyl groups. So as the number of alkyl group increases, basicity increases. But this is only valid in case of gaseous state. In gaseous state, as the number of alkyl group increases, as the number of alkyl groups increases, जैसे जैसे alkyl group की संख्या बढ़ेगी, increases, this will increase the plus I effect and thus increasing plus I effect, electron donating effect, and thus electron density intensifies on nitrogen. As the number of alkyl groups increases, electron density intensifies on nitrogen atom, and thus basic character increases. But this is only valid in gaseous state. In gaseous state, CH3NH2 से ज़्यादा बेसिक कौन होगा? CH3 whole twice NH, then CH3 whole thrice N, and least will be the ammonia. But in aqueous state, basic character depend on three factors. One is the inductive effect, plus I effect. Second is the solvation effect or hydration effect, or it is also called solvation effect, and third is the asteric effect. Let us, the anomalous consequences is observed in case of methylamine and ethylamine. So in case of aqueous solution, we observe that the basicity of CH3 whole twice NH is greater than CH3 NH2 is greater than CH3 whole thrice N. इसका मतलब क्या हुआ कि सेकेंडरी, तब फिर प्राइमरी, तब फिर टर्शरी। किस केस में? जब मिथाइल ग्रुप होगा तब, इन एक्वस सॉल्यूशन। लेटर ऑन अदर देन मिथाइल ग्रुप अगर हो, मिथाइल ग्रुप से अगर ज़्यादा होगा तो यहाँ मान लो इथाइल ग्रुप अगर लगाए तो C2H5 होल ट्वाइस NH, देन आफ्टर C2H5 होल थ्राइस N, देन C2H5 NH2। यानी यहाँ याद क्या रखोगे? सेकेंडरी, प्राइमरी और टर्शियरी, सेकेंडरी, प्राइमरी और टर्शियरी। और यहाँ याद रखोगे STP, सेकेंडरी, टर्शियरी और प्राइमरी। ये हो गया बेसिक स्ट्रेंथ। तो इन एक्वस सॉल्यूशन 3 फैक्टर्स आर important: plus I effect as well as hydration effect and the steric effect. हाइड्रेशन इफेक्ट और स्टेरिक इफेक्ट के बारे में हम लोग स्टडी करते हैं। देन कंटिन्यूइंग टुवर्ड्स द बेसिक कैरेक्टर, इन एक्वस स्टेट डाइमिथाइल एमीन, that means in this secondary case, secondary amine, then फिर primary, tertiary and then ammonia. In case of methyl, lower alkyl group, but in case of other than methyl group, the order will be secondary, tertiary, primary and then फिर ammonia. That means most basic is ethylamine in both the cases, but order will be in case of ethylamine, secondary, tertiary and primary. There are another 2 factors other than inductive effect, 2 factors as already we have discussed: a steric factor and hydration effect. What is the steric factor? Crowding of alkyl group makes the approach and binding by a proton relatively difficult. The electrons are there but path is blocked. अगर crowding ज़्यादा हो जाएगी तो फिर क्या होगा? हाइड्रेशन नहीं हो पाएगा और जिसके चलते क्या होगा? यहाँ इसकी बेसिसिटी कम जाएगी। हाइड्रेशन इफेक्ट, it refers to the stabilization of protonated amine by water molecule. The water molecule forms hydrogen bond with the protonated amine and released energy is called as hydration energy. Now see in case of 1 degree amine. 1 degree amine, just we may consider RNH2 plus H2O, it will form RNH3 plus OH minus ion. H2O and in amine, in case of H2O and amine, amines have a stronger basis than water, so it will accept H plus ion of water and it form RNH3 plus. It is protonated amine, protonated 1 degree amine. So here it is the RNH3 plus, it is the protonated amine. So we see that OH, these 3 molecules, these 3 water molecule forms and get stabilized. Alkyl group, if alkyl groups are smaller, in case of methyl, no steric hindrance to the hydrogen bonding and thus it gets stabilized. But hydration will be here in this case. In case of secondary amine, there are 2 points of hydration. In case of tertiary amine, only 1 hydration. So not only solely the solvation effect or a steric effect and inductive effect determine the basicity of amine, rather we have to consider the inductive effect, solvation effect and a steric effect too to describe the basic property of amine. And another evidence is that by knowing the value of the data of pKb, we can analyze which base is more basic, which is less basic. Now what is pKb? By applying this RnH2 plus H2O, it forms RnH3 plus OH minus ion. Applying law of mass action Kb, which is called as dissociation constant of base. Dissociation constant of base. Larger the value of Kb, a smaller will be the larger the value of Kb, a smaller will be the basic strength. In another case, we can consider pKb is equal to minus log Kb. So, a smaller the value of pKb, more stronger will be the base. A smaller the value of pKb, a stronger will be the base. A stronger will be the base. So pKb value, it has been calculated for ammonia 4.73, methylamine 3.32, in case of N-methyl methenamine 3.23, in case of tertiary amine 4.2, in where the methyl group is present. In case of if alkyl group is ethyl, so this will be the 1 degree, 2 degree, 3 degree. Now you can see, a smaller the value of pKb, a stronger will be the base. So basic strength in this case, secondary 3.23 list, so it is more basic. Secondary, then will be secondary, then primary, then tertiary, and it is 4.73, so ammonia will be the last. So basic order in this way, if alkyl group is methyl, so secondary, primary, tertiary, then ammonia. In case of if alkyl group is ethyl group is present, now you can analyze the pKb value. pKb, a smaller the pKb value, a stronger will be the base. So in this case also, secondary 2 degree, secondary, then tertiary, then primary, and lastly ammonia. So now this will be the pattern. So in case of methyl, you will remember secondary, primary, tertiary, and in case of ethyl, if alkyl group is ethyl, you will remember secondary, tertiary, primary, and then ammonia. Okay, thanking you all.